Dear viewers, we are back with a very interesting lecture on obstacle limitation surface around the airport. As you may be aware that various controls are needed around the airport during navigation. And one of main factors which we consider while selecting an airport site, as well as while deciding about the size of an airport, is the type of development which is taking place on the sites of an airport. High-rise buildings and structures are significant and one of the major criteria for airport site selection. Once site is selected, obstacles are controlled for safe air navigation. So let's understand the airport obstructions and control procedure in detail. What is obstacle limitation surface? A series of surfaces that define the limits to which objects such as buildings or towers may project into the airspace. Objects that projects through the obstacle limitation surface become obstacles. Obstacle limitation surfaces are imaginary surfaces. These airport obstructions basically are those obstructions which are provided on the sides of the airport, which are related to the type of development which has taken place at the airport and are relatedly mostly with not only with the nature of development, but also with the height of that development. So let's first discuss the definition of obstacle as per Annex 14 aerodromes. Obstacles are all fixed, whether temporary or permanent, and mobile objects or parts thereof that are located on an area intended for the surface movement of aircraft or extended above a defined surface intended to protect aircraft in flight, or it can be stand outside those defined surfaces and that have been assessed as being a hazard to air navigation. So, on the basis of this understanding, obstacle limitation surfaces can be divided into two categories: imaginary surfaces and objects with actual heights. Imaginary surfaces, where we assume that they can be any surface which may come up to this level, and therefore we have just marked some surfaces on any airport by which the aircraft should move above that particular surface, and if it is coming below of that surface, then it may be hazardous. Obstacle restrictions, like objects except for approved visual and navigational aids, must not be located within the obstacle restriction area of the airport without the specific approval of the Civil Aviation Authority. Equipment and installations which are required for air navigation purposes are to be of minimum practicable mass and height. These should be fungibly designed and mounted and sited in such a manner to reduce the hazard to aircraft to a minimum. Now suppose city is surrounding and developing, and type of development is going in the vertical direction. So what is the height of that development which will not affect the safety of aircraft operations from the airport? To understand this, we need to study obstacle limitation surfaces. And objectives of obstacle limitation surfaces are to maintain obstacles free airspace, to ensure safe aeroplane operations at the aerodromes, and to prevent the aerodromes from becoming unusable by the growth of obstacles around the aerodromes. Remember this, the obstacle limitation surfaces are conceptual imaginary surfaces associated with a runway, which identify the lower limits of an aerodrome airspace above which objects become obstacle to aircraft operations. So with this understanding, we will start our discussion on these 9 imaginary surfaces. There are different types of surfaces. which we will be looking at. And these imaginary surfaces are basically established surfaces in relation to a particular airport and to each runway. Above this imaginary surface, no obstacle should project. For each and every runway on which the aircraft is going to land or take off, assume that you are looking at some of the imaginary locations in space surrounding this runway, which aircraft will follow. So there should not be any obstacle projecting beyond this imaginary surfaces. The size of imaginary surface depends upon the category of each runway and the type of approach which has been planned for that runway. So these are the factors basically creating an effect on what type of imaginary surface of what magnitude of that imaginary surface is to be provided or assumed or any of the runway strips on any airport. So that is going to be controlled by the runway strip itself. What category of runway strip is being provided, and then with respect to that, the aircraft which are going to use that runway, on the basis of that, what type of approach is to be planned. So let's understand about runway strip first. Runway strip means a defined area including a runway and stopway. Stopway is not mandatory. So it is intended, runway strip is intended to reduce the risk of damage to aircraft running off a runway and to protect aircraft flying over it during takeoff or landing operations. Now we will discuss about the dimensions of runway strip. In approach direction from threshold, 60 meters, from runway centerline extended both sides of runway, 140 meters for code 3 and 4 and 70 meters for code 1 and 2 runway. As name suggests, RISA is the safety area at the end of runway. It is known as runway end safety area. So RISA width is twice the width of a runway, and it is extending 60 meters beyond each runway end up to a distance of 90 meters to 240 meters. RISA provides a graded area in the event that an aircraft overruns or undershoots. So with this basic understanding, we will start with the transitional surface. This is the first imaginary surface which we will be going to discuss. This diagram is trying to show the imaginary surfaces. Suppose at any airport, we have primary area. Primary area means the runway and the runway strip, which is being shown in white color. Out of this one, then slowly and slowly, the rest of surfaces keep on coming out. Transitional surface is trapezoidal in shape and it extends along the landing strip and it slopes upwards and outwards to the inner side of the next imaginary surface, which is called inner horizontal surface. It also forms part of the side of the approach surface. So this will give us better understanding. Here, some of the values have been shown in terms of side slope in percent for the transitional surface. For code 3-4 runway, transitional surfaces which starts at the edge of runway strip and it will extend upward and outward of the runway strip with a slope of 14.3%. So it means that for every 7 meters lateral distance away from runway strip, we will get a clearance height of 1 meter. Similarly, for code 1 or code 2 runway strip, which is 70 meter from runway center line, so to reach a height of 45 meter, slope is 20%. So we understand now that transitional surfaces are established for every runway intended to be used for landing. Transition surfaces starts along the runway strip and slopes outward and meet inner side of next imaginary surface, which is inner horizontal surface. An inner horizontal surface is a flat surface at a height of 45 meters above the aerodrome reference point elevation. So we started with transitional. Next is inner horizontal surface. Inner horizontal surface is an imaginary flat plane that is established around every licensed aerodrome. It can be a circular or racetrack shaped depending upon the technical details of the runway. This we will discuss. A surface located in a horizontal plane above an aerodrome and its surroundings. Dimensions of inner horizontal surface depends on runway length. So these are the technical details. It will depend upon the runway length, but height is fixed, which is 45 meters. The purpose is to protect airspace for visual circling prior to landing. So inner horizontal surface is very important for to protect the airspace for visual circling. For runway code 1 and code 2, radius of inner horizontal surface shall be measured from the aerodrome reference point, which we call as ARP. For code number 3 and 4, radius of inner horizontal surface shall be measured from runway extremity. So here we have shown a plan view of inner horizontal surface. For runway code 3 and code 4, the inner horizontal surface shall be a composite pattern which consists of two circular areas centered at the two ends with a radius of 4,000 meters. Thereafter, these areas shall be joined tangentially to form an elliptical. The height of the surface is continuous and is defined relative to the lowest runway threshold at the aerodrome. And here, the height of the inner horizontal surface is fixed, which is 45 meters. So as we have mentioned earlier that inner horizontal surface can be circular or racetrack shaped depending upon the technical details of the runway. So for that, we will be going to use this table. So we can have two types of runway, instrument runway or non-instrument runway. So for instrument runway, code 1 and 2, two circular area of radius 3000 meters. And if it is instrument runway code 3 and 4, the two circular areas are of radius 4000 meters. If our runway is non-instrument, so based upon this table, for code 1, non-instrument runway, the two circular areas are of radius 2000 meters. For code 2, non-instrument runway, the two circular areas of radius 2500 meters. And for code number 3 and 4, non-instrument runway, the two circular areas are of the radius 4000 meters. So suppose in this example, we have an aerodrome with multiple runways. So in this particular case, curves of a specified radius centered on the middle of each of the runway strips and the curves are joined by a tangential line as two curves intersect. So this is the way which will help us to determine the overall length of the inner horizontal surface of multiple runways. Now we will discuss conical surface. Conical surface shall be projected upward and outward, and it will start from the periphery of the inner horizontal surface. The slope is 5%, which means 1:20 ratio of the conical surface shall be measured in a vertical plane which is perpendicular to the inner horizontal surface. The reference datum of the conical surface shall be the aerodrome elevation, and it will extend up to the elevation of up to the height of 150 meters above aerodrome reference point. So in this figure, if you will see the green one, it's transitional surface, which is starting from the runway strip and extended upward and outward, and it is up to 45 meters. So after 45 meters, we have inner horizontal surface. So height of inner horizontal surface is a flat 45 meters, and it will extend up to 4,000 meters. And at the periphery of inner horizontal surface, we will be having our conical surface. So cone will extend outward and upward. And as we have mentioned, the slope is 5%. So above 45 meters up to 150. So 150 minus 45, it will be 105 meters. So for 105 vertical distance, the lateral distance will be 2,100 meters. So after primary surface, transition surface will start with slope upwards and outward, and it will meet the inner side of inner horizontal surface. Inner horizontal surface is at a height of 45 meters above the aerodrome reference point elevation. Thereafter, the conical surface shall be projected upwards and outwards from the periphery of the inner horizontal surface. This is one more view, which is showing relationship of our outer horizontal, conical, inner horizontal, and transitional surfaces. Now we will discuss about the outer horizontal surface. The outer horizontal surface is a plane located 150 meters above the inner horizontal surface. It shall extend to 15,000 meters radius from the aerodrome reference point for aerodrome with runway code 3 and 4. Outer horizontal surfaces for aerodrome with runway code number 1 and 2 shall not be established. So we have covered transitional surface slope 1:7, then inner horizontal surface, a flat surface at a height of 45 meters above aerodrome reference point, then conical surface slope 1:20 and height of 105 meters, which is about transitional surface. This conical surface will meet upward with outer horizontal surface. Outer horizontal surface is again flat surface like inner horizontal surface, and height of outer horizontal surface is 150 meters above the elevation, that is the level of aerodrome reference point, height of aerodrome reference point. Now we will discuss approach surface. The approach surface is an inclined plane, or you can say it's a combination of planes which originate from the inner edge associated with the each runway threshold. So you suppose that your runway is ending threshold, that will be the inner edge, and as you are moving towards right in this figure, so it will be having an outer edge. That will be more clear in the next next slide. So it will be having two sides, inner edge and outer edge. The inner edge is associated with each runway threshold, and it has a specified length and is located horizontally and perpendicularly to the runway centerline at a specified distance before the threshold. The two sides diverge also uniformly at a specified rate from the extended centerline of the runway. So this will become clear with this. The approach surface we have divided into three sections and ends at an outer edge that is located at a specified overall distance from the inner edge, and the outer edge is parallel to the inner edge. This data which we are shown in this particular picture is for instrument runway code 3 and 4. So for other it will change. So length of inner edge, if you will see towards left side, it's 300 meters length, and length of outer edge, which is shown towards the right, is 4,800 meters. And overall length of these three sections, first section, second section, and third section, is overall length is 15 kilometers. Now, as we have told that if you will extend the runway extremities and you will calculate the divergence, it is diverging both sides. So it is 15% divergence. And the slope, as the aircraft is approaching from right side, it will descend and it will land. So slope is 2%, for first section, which is having a length of 3000 meters. Thereafter, slope is increasing 2.5%. Length is 3600 meters. After this, the third section is a flat. So second section is having a slope of 2.5. Where it has reached, it will become flat. And as we are aware that in most of the non-precision approaches or precision approaches, the aircraft is coming with a 3-degree glide slope or relative percentage. So this particular approach surface, imaginary surface, is maximum up to 2.5%. So above this, aircraft can safely travel and it can land. It can make a safe approach towards the runway threshold. So this is the table for instrument runway, which we have already discussed. And this is the table for non-instrument runway. Now we will discuss about the takeoff climb surface. So the origin of the takeoff climb surface, it will start with the inner edge of a specified length. And it is located at a specified distance from the end of the runway or the clearway. The plane from the inner edge slope upwards at a specified rate, with the two sides of the plane originating from the ends of the inner edge concurrently diverging uniformly outwards at a specified rate to a specified final width and continuing thereafter at that weight for the remainder of the specified overall length of the takeoff climb surface until it reaches the outer edge, which is horizontal and perpendicular to the takeoff track. So why it is diverging? It is diverging so that if any aircraft is taking off, it is turning left or right, so it should protect that one. So initially aircraft will climb a runway heading, it will gain a sufficient height to clear off all the obstacles. So once it will attain a particular height, it can take left or right, or a route designer can plan routes accordingly. So it is diverging also in both sides. So this will give what we have discussed. It will give a clear idea here. So it is also similar to like approach one. So at the end of runway, or you can say at the end of clearway, we have a length, we have a inner edge, which as we have shown towards left hand side. So length of the inner edge is 180 meters, and as we are going towards right, so final width, which is shown for code 3 and 4, is 1800 meters. Overall length, which we have already told, is of 15 kilometers, and the rate of divergence is 12.5%. So while making an approach, that rate of divergence is 15%, and here it is 12.5%. Slope is 2%. Now this is the table which we have just discussed for the dimensions of takeoff climb surface. Now this is very important and very good. It will give you a clear idea that what we have discussed earlier. This is section view of surfaces. Whatever we have discussed so far, it is clearly shown here. You can pause your video and you can observe the same. Whatever we have discussed earlier, it will give you all understanding. So now, what is obstacle free zone? The inner approach, inner transitional, and bark landing surfaces together define a volume of airspace which is in the immediate vicinity of a precision approach runway, and this is known as obstacle free zone. So this zone must be kept free from fixed objects. So other than lightweight frangibly mounted aids to air navigation, which are very close to the runway, that they have to perform their function, and for transient objects such as aircraft and vehicles when the runway is being used for precision approaches. So other than that, there should not be any obstacle. So now we will discuss about the first inner approach surface. Inner approach surface as you can see, it's a rectangular portion of the approach surface, and it is immediately preceding the threshold. So the inner approach surface originates from an inner edge of a specified length at the same location as the inner edge for the approach surface, and it extends on two sides parallel to the vertical plane containing the runway's center line to an outer edge which is located at a specified distance to the inner edge, and this outer edge is parallel to the inner edge. So it's almost like a rectangular portion. So inner transition surface. Inner transition surface is similar to the transition surface but closer to the runway. The lower edge of this surface originates from the end of the inner approach surface extended down the side of the inner approach surface to the inner edge of that surface. So along the runway strip to the inner edge of the bark landing surface, and from there up the side of bark landing surface to the point where the side intersects the inner horizontal surface. So the inner transition surface should be used as a controlling surface for navigational aids, aircraft, and vehicle holding positions which has to be located near the runway. The transition surface should be used for building height control measures. Now we will discuss about the bark landing surfaces. The bark landing surfaces is an inclined plane originating at a specified distance after the threshold and extended between the inner transitional surfaces. The bark landing surface originates from an inner edge of a specified length located horizontally and perpendicularly to the center of the runway, with two sides from the ends of the inner edge diverging uniformly at a specified rate from the vertical plane containing the center line of the runway, ending at an outer edge located in the plane of inner horizontal surface. So the elevation of the inner edge is to be equal to the elevation of the runway's center line at the location of the inner edge. The specified slope of bark landing surface is to be measured in the vertical plane containing the center line of the runway. So, sorry, length of the inner edge for Cat 1 is 90 meters, and if we are going for Cat 2 and Cat 3 operations, the length of inner edge will be 120 meters. As we have told that it will diverge also both sides, so divergence is 10%. Distance from threshold is 1,800 meters, and slope is 4% for category 1, and for Cat 2 and Cat 3 it is 3.33%. So with this, viewer, we have come to the end of this session. If you like this video, please press like button, and I request all new visitors, viewers who have not subscribed this channel, please subscribe for more such informative videos. Thank you. Thanks for watching.